Thanks very much. Thanks very much, Ken. So I'd like to start out by a quick apology. I was subbed in to give this talk. It's something I've been thinking about for a while, but actually writing the slides has consumed the last few days and even this morning. And also the obvious thing here is this is not, names don't matter does not mean that we can all call each other anything we want. Right? You have a name. Names themselves have some value because really identifiers got to identify things. Okay, so it is not an argument saying that identification of things via words is a pointless exercise. Right? Let's get that out of the way. Right, so names don't matter. Right, you've probably heard this uttered by, as Ken said, a vocal minority of functional programmers usually, often who are working in strongly typed library. Right? But then these same people will then demand that particular names are actually really important and we should use them. Right? Clearly, hypocrites. So if you demand names don't matter, what is your problem with changing the name to something that's nicer, like, you know, warm fuzzy thing or pipe-like or something like this? However, if you demand that names do matter, why are you so willing to change them? Right? So the question is, who actually is the hypocrite? Right. So, firstly, we should actually start with some definitions. What is in a name? Right? Juliet Capulet, whose lover, Romeo's family, the Montagues, and hers are in a deadly feud. And she asks, what is Montague? It isn't hand or foot nor arm nor face nor any other part belonging to a man. Oh, be some other name. What is in a name? That which we call a rose by any other name would smell as sweet. So what is a name? It's a noun, right, obviously. A word or combination of words by which a person, place, thing, body or class or any object of thought is designated, called or known. Right? And some other thing that we could maybe use descriptively in honour or abuse. So what is a word? Again, a unit of language consisting of one or more spoken sounds or their written representation that function as a principal carrier of meaning. And these words themselves are essentially a random collection of sounds or morphemes. So what's this mean? A principal carrier of meaning. Well, words carry meaning based on the shared understanding that between the two communicating parties. So if I use a word in a language that you don't understand, it is essentially useless as a form of communication. Right? And without that shared understanding, we have no, the value is reduced. And yet, the actual morphemes themselves are arbitrary. Somebody chose them, and we've all basically adopted that particular set of morphemes to have a meaning that we've all understood during our lives or adopted. And if we don't have shared meaning, well, we have two options, right? We can either use another word, which hopefully has the shared meaning that we want, or we can teach that meaning, and then now we have the shared meaning that we want. Right? So words, however, you know, despite this idea of them being principal carriers of meaning, they're quite imprecise. We use synonyms, so we have multiple words that relate to the same or very similar meanings. We overload meanings, so we use different words to mean the same thing, just to confuse us all. And we speak multiple languages. Right? So we have entire dictionaries of words that all have the same meanings in other languages. And so we can think of each word as simply an association of those particular morphemes to an actual meaning. Right? And if it's merely an association, can the actual meaning be referenced in a more stable or canonical form? That's the question. Right, so this names don't matter is particularly relevant to programmers. Why? Well, we usually reference the Knuth quote from Literate Programming, where the programs we write are secondarily important to how they operate, but primarily important to communicating that meaning to me, the programmer, when I come back to it, or to my teammates, or to the wider world. Right? That's very important. And of course, there are obviously two hard problems in computer science, right? But obviously, name is one of them. Okay, so the reason it matters is many of the abstractions that we programmers have traditionally built have only had informal or poor specification. We have just this thing, we're not really sure what it is, but we think it's kind of like a builder, maybe, right? Hands up who knows what a builder is? Anyone? Okay, keep your hands up if you also know what a factory is. Okay, can anyone tell me the difference? Nobody. Nope. You can build in multiple steps. You can pass builder around, but the factory happens once, the one go. Really? Is that that's guaranteed? So all right. Okay. Cool. All right. So we have this lack of abstractive power in our languages, right, and our type systems. So we haven't really been able to build, to construct things that which have like truly general properties, and they're very difficult to reuse. And in attempting to sort of convey these meanings, we've essentially had two options. Generally, we have documentation and we have names. And so, we can add stuff to our documentation, but we're usually kind of searching for the right name because, it's really important to convey this idea that my thing is a factory, or no, it's a builder, or maybe it's an abstract proxy bean factory, or something like this. And of course, in many programming contexts, names are basically all we've got apart from documentation, but they're the primary thing we have. We have no other tools, particularly in unityped languages. So we kind of essentially are often looking for the right synonym that will carry some kind of metaphorical connection to something else that we already know. Because of course, programmers already know everything, and if we just have a metaphor to some other thing that we already know, then we'll understand what a monad is, right? And of course, what this means is every single library and every language uses different names to refer to the same thing, right? And we justify this because names matter. All right, so for example, all right, so we're all functional programmers, we know what this is. Okay, Haskell programmers also know this as bind. Scala programmers know this as flat map. Then Java's completion stage has then compose and then compose async, depending on whether you want to run it on different thread pools or something. Anyway, it's called select many in C#'s link. JavaScript promises call it then, sort of. They actually want to call it smush map. Right. All right. Now these are almost all the same thing. Promises then is not really the same thing, but we just pretend it is for this talk. And how do we know? Well, we look at the type. Okay, so essentially, all of these things have the same shape. So we have a thing where we say simply for some monad thing, we have the ability to construct a function which has this shape. It says given a container that has A's in it and a function that takes an A and returns a container that has B's in it, then we can return a container that has B's in it. Okay? And that's essentially the shape along with a few laws. Right? And essentially all this is the sequential composition of two actions. Right? So the name here is not the most important identifying feature. Right? The type and the laws are the things that actually matter. So for instance, here's a function called Fred. Right? Fred says, for all A's, given an A, return me an A. Right? And if we believe the hypothesis that fast and loose reasoning is morally correct, which I'll give you a link to, which essentially says that you don't do dodgy bad things. Right? You don't throw exceptions, you don't, you actually terminate, you don't do typecasing or runtime reflection. Then we can tell, as long as this fast and loose reasoning applies, that this is definitely not Fred is the same as Fred. Right? These are the same thing, and we know this because of the type. The name here is not the most important thing. The type is more important. This is AKA, anyone? Id, identity, right? There's a couple of other little names, but generally. All right, here's another function. Upset says for all A, given a list of A, return me a list of A. This function signature is not enough, right, to tell me all of the things that I know. However, I can tell you a few things about it, given the type signature. Specifically, that no element in the output is not also present in the input. Okay, so there's no made up A's in the output. But if we add a law, it says for all A, where I have two lists, B's and C's, which both contain A's, and if I upset B's appended to C's, then this is the same as upsetting C's plus upsetting B's. Now I know exactly what this does, given a type and a law, and I can AKA this as reverse. Right. And this idea that we can just use types and not names generalizes even to pictograms. Brian tweeted this. It says that Spanner, he made a small mistake, takes two arguments and returns a single argument of type bathtub. Right? And we have a law that says for all dinosaurs, horses and cows of the same type, the spanner of dinosaur, horse and cow is the same as spanner of dinosaur and spanner of horse and cow. Right? So anyone know what that law is? Associativity. Right? So we can actually now work out what a common name for this is. Anyone? Semigroup. Which is the name that maths would recognise. How am I doing? Okay, so arguments, right? So argument names are important, usually if looking them up is difficult. If the context by which we're using an argument is very different to the context in which, or distant from the context in which it's declared, then it's often important that we relate them back. And in monomorphic code, where the argument A is an amount and argument B is a rate, and we're working out a tax rate, well, we'd probably call them amount and rate, right? But in polymorphic code, arguments are often for all types, and so they really lack any definition. So if we go to Fred, we could have an implementation of Fred that has a nice descriptive argument name, right? And it's actually possibly a bit less readable than the one that just uses a very short variable name and uses it directly after it is declared. And of course, sometimes the best names are no names at all if we have to manufacture a name. So given our definition of the class monad, we have two functions, return and bind, and we have fmap. Guess what? We can implement fmap using return and bind. So for instance, we can say fmap of an MA followed by a function from A to MB. Then we can declare a lambda, which name the argument A, and then we apply the A to get a B, and then we turn that B into an M of B by using return. Okay, so we're composing those two functions by hand. But we can actually do that using function composition, and we don't need a name at all. Much nicer. Although this can actually get a little bit crazy. We can take it to this, and then maybe we might fully do this. And now we've got rid of MA and F entirely. And right, so I forgot to bring these up things. So we often balk at the difficult names of mathematics. And usually that's because mathematicians are really bad at naming things, right? And ask Dr. Cheng, please, why that's the case. So these names, though, have existing meaning and a lot of literature, and that's really valuable. Ed talks about having used a lot of these names like codensity and so on, and how that allowed a whole bunch of mathematicians to come and pile on him and tell him how he was using them incorrectly, or maybe that suggest additional things that the maths would suggest, and therefore he was able to improve his library by using the original names. Right? And there was a Twitter bijection library whereby they said they used bijection just to mean, oh, we'll just have some random relation between two things, rather than a proper bijection, which is where all the elements of set A match into the elements of set B, and back again. And the use of the word led to that library being improved. Okay, so I'm running out of time, so we'll go through this a bit quickly. What does matters actually mean? Right, so we accept that names matter, then we need to really define matters. Right, so I propose that something matters if changing it has a material difference. I can add multiple names to things without changing their essential meaning. I can give them a synonym, I can use that synonym, I can call Josh Fred, and he might not like it, but he he hasn't essentially changed. Right? My mum calls me a string of names. She says, oh, Digby, Martin, John, whatever, and I'm just like, yeah, whatever, Mum, hi. But if we change types or laws, then we fundamentally change the meaning and the behaviour of a program. So I would propose that types and laws matter more than names. And this is kind of essentially the point of this argument. And if names don't matter, right, doesn't mean, oh, we can just go and change things willy-nilly. Right? Names don't matter means we should actually carefully choose the ergonomic factors that we care about in the names. Right? So not just for the adoptability or the associativity for a new reader. Right? We can choose other things, like the fact that there is a bunch of there's a bunch of existing literature on the meaning of these things. Right? And if we're going to pick names, well, we should not use names that have already got a precise definition in another field. Right? Isomorphic JavaScript, they've chosen to mean JavaScript that runs on the client and the server. But isomorphism has a very specific meaning that doesn't mean just runs on clients and servers, right? Stability of identifiers is important. Right? If names matter, let's not change them all the time. Right? And naming new concepts is hard. Right? There's nothing going to get us away from that. So, let's go and argue about them. Thank you very much.